Today you're going to be introduced to a new irrational number. This irrational number is called E. So E, you have to know, is an irrational number and used in continuous compound problems. So we're going to use this E. I'll show you where to use it on your calculator. So get your calculator out now and show you where to find it. So E is an irrational number that's approximately 2.718. Some other irrational numbers that you guys know is pi. Pi, you know, goes for forever, but we approximate it to be 3.14. Then I don't know if from first semester if you guys remember the little special I. Remember what I was? I was the square root of a -1. So in math we have some different variables, and these variable E is what we're going to work with today. So first of all, I just want to make sure that you know how to find E on your calculator. So there's two places that you can find E on your calculator. One is atop the division sign, and then there's another place on top of the LN button. So if I don't have a power, like in 1A, when you just want to use E, I just usually use the second division sign because that'll just give me E. So again, the calculator has a built-in value for this. You just have to know how to use it. If in part B we have an E to the fourth, I'll show you the difference here. When you do second ln, E automatically goes to the power. So if you put in E to the fourth, you'll get that value. I brought in the other model. If we hit second ln here, this is what the power button looks like, but again, you'll get the same result. So in number one, it's just a punching exercise. E raised to a negative power. You just put that negative power in there. You'll get a decimal. Usually we round to 3 decimal places. E to the 0, you might be surprised, is equal to 1, but remember, anything to the 0 power equals 1. So in example 2, I just want to remind you of our power rules. They work the same exact way that if we had an x to the power and x to the power, what do? We just add those powers. If we have an e to the 8th and e to the 11th and we're dividing, we subtract those powers. 60/18 we reduce, and 6 goes into 60 10 times, 6 goes into 18 3 times. A way that you might do that on the calculator is if you put 60/18, remember on your calculator if you hit math, fraction, that will reduce it for you. A power to a power, we take -10 to the 4th, and then a power to a power, we multiply powers. So you would punch out -10. Again, remember, negative powers, we have to put in parentheses, so we'd get 10,000 here. E, power to a power, we multiply the powers and get -20x. So stop the tape, try 3 as a check, and then I will put final answers up in a second before we start some graphing. So number 3A, same basis, we add the exponents. Reduce 12/3, we get 4th. Subtract exponents, we just get an e to the first, and usually we don't write that. I got a 125 by taking 5 cubed, e to the power. We multiply these powers, and that's where the 9x came from. So we'll use these when we're talking about compound continuous problems. So we will have decay problems, and we'll have exponential growth. And how are you going to be able to tell those? So we'll have a similar, we've just got done doing a b to the x. Today we'll look at a. What is a still? A is still the initial value. But now we'll have things that will grow or decay according to this e value. And we'll have a rate, and we'll have, again, x will be the same time component. So if r is positive, we will have a exponential growth. That's what this says. R is positive. If r is negative, we'll have a decay problem. So similar, we'll have an a, we'll have an e raised to the r. You might be able to identify the rate. In this case, r would be a 0.6. If we were talking about percent, this would mean that we'd have a 60% increase. So let's see what that graph might look like. So again, take out your calculator. The best bet on these is to start off with a zoom and then come down here to 6 to start your calculator off in standard window. When you go to your y equals, how do you get that e to the power? Hit second ln, and then your e to the power automatically come in. On this model, we'll put the whole exponent inside parentheses. When we graph it, it'll be similar to the exponential equation, but our base is e, and remember what e is, it's 2.718. So we'll have some shape that will look similar to the exponential. Hit second graph, and these points will be a little decimal, but still just kind of get a basic shape of what this looks like. You can see again, as x gets really small, we're going down to 0. We have a 0.02, 1, 3, 0.6, and negative 1, 1, 0.0, and we're kind of coming down, and we're headed to the x-axis. So again, make sure that you level these graphs off, show that they go up forever. And these are called exponential graphs again because we have an x in the exponent. I'll have you graph a few of these and just see how they're similar and how they're a little different. Graphing part B, you can see that 4 moved your graph up. This x minus 1 shifted your graph over a little. Okay, so check that your graph kind of went up and then over. We talk about the domain again. Domain is all reals. Range is how the up and down is affected. So we can see that this is always greater than 4. When you punch number 5 in, you'll see that we have what we call a decay. And again, look at your exponent. Your exponent's negative, so we should have a decline. When you punch it in, if you hit second graph, again, the table will give you some points. How many points should you make? Probably make about 3. So we've got 0, 1, 2, 3, 4, 5. We have 1, almost 4. Negative 1, we have a 7 something. You can kind of get that basic shape. Where is this headed? If you can't see where it's headed here, tab down in your table or look at your graph and see where it levels off. But again, when you graph these things, make sure that you show how it levels off because all exponential functions graph should level off, and that's how we determine the domain and range. So again, if I ask you, domain would be all reals, range would be y, in this case, is greater than 3. So I'll have you practice some graphing problems, and then we'll come back and do the word problem section.